With me are Wawrzyniec Zwieniawski, Piotr Masierak, and Andrzej Tomski. They are co-authors of our recent article on assembly theory, which is now under review. And well, I'm honored to be with you. I'm honored to be able to present the results of our calculations of our research to your group, because I've been following you for some time, and I am really impressed by what you're doing to planaria, axolots, and all those animals, making them three-headed and so on, and working against the dominant block universe paradigm that I don't like much. Okay. So perhaps I will share the screen with you. Okay. I believe I shared the screen now, yes?
Yes.
Okay. So I'd like to start with the consciousness cause collapse. This is one of the interpretations of the quantum measurement problem. And for a long, long time, I believed that this is it does that. Not consciousness, but we live by the present moment, and within the present moment, we make quantum measurements. And I believe that this is a common situation, and everybody shares this perspective. Until very recently, when 8 years ago, I've learned about an experiment in which the authors decided to wanted to confirm this idea, and to do that, they built a electromagnetically shielded chamber in which they put a double-slit device in a computer, and then introduced participants one by one. And the computer announced randomly commands like focus, don't focus, focus, don't focus. And the results allegedly show that while those participants were focusing on this double-slit device, they were destroying the interference pattern. In particular, if they were meditators or some people with increasing level of openness and so on. Well, I thought this is simply ridiculous, because my quantum TV set would not be working if there were any meditator in the room. Not to mention some attacks on quantum computers from some meditating people. So only then I realized that I was thinking about something else. So certainly it's not consciousness that causes collapse, no mystic brain waves or whatever. This is life that causes collapse, and every living cell conducts quantum measurement, in which it converts quantum information to classical one, not always precisely, and then conveys this information to other cells. So, for example, neural network of a human brain has a quantum foundation, because each neuron is a biological cell, but then the transmission of the information is classical. Why a case against teleophobia? Well, we have so many different terms basically to convey the same meaning. It reminds me of the situation of the Rwandan genocide in 1994. I was in Rwanda 15 years ago because I was amazed how come that 800, almost 1 million people was killed in 3 months. That was the most efficient genocide in human history. And at the beginning of the genocide, they didn't call it a genocide. They called it acts of genocides, not to... I mean, this is perhaps the part of human nature, not to name things as they should be named. And I believe that the same phenomenon is here, because so different definitions like... I'm with Dr. Levin with his definition of teleophobia as an unwarranted fear of erring on the side of too much agency in explaining or predicting the behavior of a system. So for me, living organisms are clearly governed by different principles than dead organisms, because living organisms are goal-oriented, while and we are dissipative structures working locally against the second law of thermodynamics. In this particular research, we found something peculiar, namely that the humility of not having a predefined scientific goal is helpful because Stefan Bürgermeister, if I understand him correctly, said that assuming is stifling. So we realize that not assume the course of action of where will it go is better than stick to some predefined goals. So the most important question is, if I realized, would be to ask how come that a qubit, the basic unit of quantum information, turn into a bit, because the qubit is the quantum information is infinite, and the opposites, the quantum states 0 and 1, there are infinitely many parts of them, while in classical domain there are only two, 0 and 1. So this conversion of a qubit into a bit would be essential. Then I've learned about the holographic principle, according to which one Boolean variable per Planckian surface element is assigned on some distant two-dimensional surface. Well, it doesn't answer how distant is this surface, and this idea is in a way incomplete. But then I've learned about Pierre Taylor de Chardin concept of within and without, and its association with the spherical coordinate system. And only recently I've learned about Donald Hoffman interface theory of perception, according to which perceptual experiences do not match or approximate veridical properties of the objective reality. And this is something I entirely agree with. So I'm convinced that the holographic principle provides a prototype of a bit as a Planckian area, and the same bit would be used on the surface of a black hole, on a two-dimensional holographic screen, and on a biological cell interface. An example of a perceptual experience is the notion of an object, but then we have the ugly duckling theorem, which was derived by Satoshi Watanabe in 1969, that establishes that any two different objects are indistinguishable. This is the most likely the zaniest theorem ever, because it's so it defies common logic. I mean, how living would be possible in a world when every two objects we perceive are equally possible, equally indistinguishable. But this is mathematics, so that's how it is, and we should rather draw conclusions from this result than try to say that it's not the case. Watanabe himself was so puzzled with this result that he proposed, as a corollary of his theorem, that we have to assign weights to the questions that we ask the reality. For example, let us consider three objects. We can assign them to 8 groups only that we can say might correspond to questions that we ask to those objects. So to the first question, all objects would answer negatively, and to the last question, all objects would answer affirmatively. But any two objects share 4 groups only, meaning that they are equally indistinguishable. So Watanabe's suggestion was to assign weights, like saying that question 2 and 5 would be more important than questions 3 and 7. And this is true. And this is how we learn to discern. And I believe that this is how our perception works. But by no means can such an observation be equal to a corollary of a mathematical theorem. It's just a rule of thumb. A fundamental holographic screen is a black hole, which is one real number. Any black hole, rotating, charged, and so on, can be reduced to a non-rotating and uncharged by the Penrose process. So we can say that it can be represented by its diameter, conveniently expressed in units of Planck length, or equivalently by its mass, by its radius, by its information capacity, meaning the number of Planck areas on its surface,
This is a nice formula because it relates the number of Planck areas with the multiplier of this diameter. I mean, we express diameter in terms of multiplicities of a Planck, the Planck length, and this is this real number that multiplies those Planck lengths. Or Bekenstein-Hawking entropy, or temperature, also Bekenstein-Hawking temperature, which, as we see, is a kind of a reduced Planck temperature, again with this dBH in the denominator. By black hole energy, by black hole entropic work or average energy, which is just the product of temperature and entropy, and it equals half of the black hole total energy. Black holes emit black body radiation that also depends on one parameter. Commonly it is temperature, but it can be anything else. In 2010, Eric Verlinde introduced something he called variation of entropy, motivated by the holographic principle. And he related it to, as a function, this variation of entropy was a function of a reduced Compton wavelength. And he proposed the following formula. So the only two parameters are mass m and delta r, the distance from the holographic screen. I am convinced that gravity is entropic, even though scientific community is skeptical about it. Namely, to clean the room, I will need not only energy, but some predefined structure of information, like a vacuum cleaner, for example. And this holds true for any, say, anti-entropic action. But the same holds true for gravity. To climb a stairs or to fly into space, I'll need not only energy, say rocket fuel, but I also need a rocket or legs, for example, if I want to climb those stairs. This is, I believe, reflects the universally entropic trend of gravity. So with this particularly simple trick, Verlinde was able to recover, it is possible to recover, actually this is an equation we derived, not Verlinde, to Andrew Davis temperature, relating temperature with the acceleration. We start with the formula for the work as a product of force and the variation of position or of temperature and variation of entropy, and we end up with the Davis-Andrew temperature without any general relativity, but by simple substitution of this entropy variation. The same way we can derive the force and the Newton's second law, the inertial force. It's a bit circular definition because here we use this temperature that we derived before. We can derive the Newton's gravitation by introducing gravity instead of acceleration to the Andrew Davis temperature. And finally, we can also derive the black hole entropy simply by expressing by mass here in this fraction by the radius, by the black hole radius, and it all simplifies to this. Only 2 months later, after the Verlinde preprinted his results in February 2010, Sabine Hossenfelder proposed another variation entropy. This time, she generalized Bekenstein-Hawking entropy, and she used gravitational potential and equipotential surface A. So introducing the gravitational potential of a black hole and the black hole surface, it also turns into Bekenstein-Hawking black hole entropy. So I realized that this can be expressed as summation. So by multiplying by c squared, we introduced the Planck area in the denominator here, which allowed us to introduce a quantity I call it an A, and this will be the number of Planck areas on the holographic screen. And what was left was to define
the unit of potential assigned to this Planck area in order to get rid of the c squared in the denominator. So I propose that it should be defined in the units of negative squared speed of light. And I mean, like, it should be binary because we are assigning this potential to one bit, but in units of the minus c squared. And by simple comparison of these two results, namely the Bekenstein-Hawking entropy and this simplification of this formula, namely after summing up all these Planck areas, we will take into account only those which are ones in units of c squared. So c squared will drop out along with this minus sign, and we are left with it. And then if we compare it, we see that the number of active Planck areas on a black hole is equal to half of all those Planck areas, which makes the black hole not only the material, quote-unquote, object having the largest possible entropy, but also an object having a maximum Shannon binary entropy, because it turns a black hole into a binary balanced string. Later on, we found that black holes are also ergodic systems. So why do we claim that bits are spherical? Well, this is a result I found in the book on discrete differential forms for computational modeling. The authors say that, to which I agree, the traditional use of a coordinate system in which the defining equations are expressed often obscures the underlying structures by an overwhelming usage of indices. Moreover, such complex expressions entangle the topological and geometrical content of the model. So by triangulation or simplification, using the simplicial complexes instead of a continuum models, we can disentangle the topological and geometrical contents of the model. Furthermore, I also noticed that on a two-dimensional surface, two possible triangulation of a square produces the same Cotton Laplacian. Cotton Laplacian is the Laplacian for discrete cases, and I think it should be related with Laplace's Poisson's equations for gravity, but it's just a wild guess at this moment. So we've learned that black holes are ergodic, meaning that the time average of measurements of a single black hole, a Planck triangle, would be called the average of measurements of all Planck triangles. It starts with the famous Heisenberg uncertainty theorem for a standard deviation of energy and standard deviation of time. Later on, it was found that the similar bounds exist for this time for a quantum orthogonalization interval of a quantum system. So we start with a quantum state expressed as a superposition of energy eigenstates. We let the state evolve for some time, that becomes this one. And then we ask ourselves about the shortest interval needed for this evolved state to be orthogonal to the initial one. And it turns that the same bounds hold for the average energy of the quantum system and the standard deviation of it. Later on, it was found that both these bounds are attained, namely they become equalities, if the quantum system in the subject quantum system is a qubit of equal superposition of two energy states 0 and 1 and E1. Well, this is peculiar result because there are no quantum systems having the zero ground energy. This is known as the vacuum catastrophe, is considered one of the unsolved problems of physics. Within the block universe context, dropping this context, it's not a problem at all. And for example, we see that the black hole is the object that can be considered this qubit. because it was found that the E1 energy, the highest energy agent state, is bounded. It should be larger than half of the maximum energy of the system and equal to the maximum energy of the system. And here we got a black hole, namely the energy agent state, non-zero, non-vanishing eigenstate, equals the maximum. So we are at this at the right side. And these two drawings show us the some intermediate situations. I think that it can be assigned to a photon, which we know has only one energy given by Planck relation, and is perhaps also related to the black body radiation temperature, but also this is something we are researching. So this bound, for example, can be also expressed in terms of the information capacity by simply expressing that, assuming that we are talking about the black hole, so Emax is the black hole energy, and then we switch from black hole energy to radius on information capacity, which introduces us a peculiar sphere surrounding each black hole. Well, this sphere is the right bottom corner of every slide of this presentation. And we don't know what does it mean and where does it go, but this is mathematics, so we will be looking forward to find out some solutions. I believe it may be related with the assembly theory and the notion of bin mutation, but again, this is hypothetical at this very moment. Interestingly, the same bound, or closely the same bound, can be obtained if we consider an object orbiting a mass of mass m at radius r. And of course, the orbiting condition is that the velocity of this object should be larger than orbital velocity and smaller than escape velocity. Now, if we express the velocity of these orbiting objects as in units of speed of light in vacuum, and we consider squares of these velocities, not to drop square roots, then we see that all of a sudden we have black hole ready at both sides of these bounds. Of course, I had to multiply by 2 to get this 2 in. And again, we can convert it to radius and information capacity, and we arrive at this bound, which is almost the same like this bound, with the difference being the velocity factor, which becomes 1. So these bounds are equal to each other if the velocity is c divided by the velocity of light divided by the square root of 2. This is the velocity at which the de Broglie wavelength of mass m equals the Compton wavelength of mass m, which is we find peculiar. So assuming that all holographic screens are spherical, we postulated the Pythagorean relation. So relativity is grounded on Mach's principle, and Mach's principle, introduced to physics by Ernst Mach, can be paraphrased in simple thought experiments. So imagine that yourself standing in the field, looking at the stars above. Your hands would be dangling freely and the stars would be unmoving. But when you start spinning, then you'll see that the stars are rotating and your arms are being pulled away. Well, I believe that this shows that not only the biosphere is a collective intelligence, as you postulate, but the whole universe is in a way a collective intelligence. Because why would the stars be unmoving? Why would the movement of my hands be correlated with the rotation of the stars? Most interestingly, if I was in a planetarium and the planetarium staff would make the stars wheel above my head, my hands would not be moving, meaning that velocity can be simulated, which so we postulate that the observable velocity is the tangential velocity, while the unobservable is the radial one. In fact, it's easy to see that this Pythagorean relation is sewn into the Lorentz factor relativity. Further, it was shown in 2018 that the relativistic combination of Pythagorean velocities, parallel Pythagorean velocity, is also a Pythagorean velocity. So this relation seems to be correct. As for acceleration, we also bounded two accelerations with each other using a Pythagorean relation. This time, radial acceleration is unobservable because radiation acceleration is felt. And we postulated that unobservable is the tangential one. But we know the relation between temperature and acceleration, so we could have used it. And it introduced the square root. And for the tangential acceleration to be a real number, we demand that the argument of the square root is positive. Otherwise, we would have an imaginary quantity. So this showed that the Andrew-Davis temperature must be larger than the reduced Planck temperature, and also introduced kind of a minimum black hole, namely a pi-bit black hole, namely a black hole with a diameter equal to Planck length. Such a black hole could look like this, and it has three Planck triangles and a fractional triangle at the south pole. Interestingly, the four triangles are the minimum number of triangles required to triangulate a sphere. This is a 4-pi-bit black hole containing 18 triangles, 12 Planck triangles, and 6 fractional triangles on the equator that are responsible for this fractional part, which is too small to carry a single bit of information. We believe that this is related to the notion of uncomputability, and in particular that life has access to this uncomputability as that is not inaccessible to the computable machines. I mean, Turing machines, artificial intelligence, and so on. We can also express the energy of a black hole in this form, which for a pi-bit black hole provides us with something I would imagine to be a corrected form of a equipartition theorem for an ideal monoatomic gas. So the equipartition theorem for 1 degree of freedom was rigorously proven. And under the assumption that the degree of freedom depends quadratically on the generalized coordinate. This holds for the Planck area and the associated quadratic potential, as in our case. This is a trick I made, we of course this cancel out, to make this formula look like this and show you that 1 degree of freedom, this is the original equipartition theorem, corresponds to the black hole having only 1 bit of information. Of course, the notion of a triangulation of such a black hole becomes problematic, but later on we'll see that the area of a sphere in a complex dimension is not a real number. Another formula for energy of a bit is known as the Landauer principle. It should be called theorem because it was rigorously proved by Landauer, and it says how much energy is required it specifies the minimum amount of energy required to erase 1 bit of information at temperature T. So at the same temperature, Landauer's energy is larger than equipartition energy, which we can interpret as erasing a bit costs more than perceiving a bit, and intuitively it makes sense because our withins are smaller by Jordan-Brouwer separation theorem, the interior is bounded while the exterior is unbounded. So the interior is smaller, which requires compression of signal within the biological network. This is the idea of a selflet that was I found at one of Dr. Levin's presentation, but it perhaps would be it should be mentioned that Vlad Koveda and his team also analyzed models of predictive models, and they found that any classical model must record each binary property conditioning the system's future behavior. Here, X with the arrow is the random variable that governs the future system behaviors, and the conditional probability of this random variable, with the condition that A was realized as 0, is different than with the condition that A was realized as 1. So each such a binary property must be recorded by the system, regardless of how much those two distributions overlap. In case those distributions are not orthogonal to each other, quantum model can partially discard those information, retaining enough information to recover statistical differences. So I believe that these results are correlated and provide additional arguments for the interface theory of perception, the fact that life explains the measurement problem. So this is the drawing again taken from Dr. Levin's article. I am entirely on the right side of this diagram, albeit I believe that the answer is twofold, namely, to the question, can embodiment occur in a problem spaces other than 3D? I believe that the answer is yes or no. Indeed, we are surrounded by hard to visualize, diverse intelligences, cells working and so on, working metabolic, physiological, transcriptional, morphological, and so on, multidimensional spaces. But yet we all perceive the world as in three spatial dimension and imaginary time, and I believe that every living being perceives the world this way, and this is because of the exotic R4 property of such a space. This is a mathematical property that asserts that there is a continuum of homeomorphic shape-preserving structure that are not diffeomorphic to each other only in 4 dimensions. In other dimensionalities, there is no such property. So I believe that we have to relate it to this is the Euclidean space of 3 real dimension, imaginary dimension. For example, we can distinct objects into being distinguishable, indistinguishable, eternal, temporary, and perhaps with the additional definition of atemporal partial mathematical truth. So within, I had a problem with finding the distinguishable eternal object. I believe that the universe is such an object. And what I found funny is that when we consider distinguishable object, we admit subjectivity, but for indistinguishable objects, we are more prone to look for some stiff definitions, universal truth, which I believe not always is possible. I mean, it's certainly possible for a circle, because a definition of a circle is precise. It's a set of points equidistant from some other points known as called as center of the circle by the same distance. So if we only agree on the meaning of a notion of a point and distance, we have the same specific definition of a circle. But there are many notions that are not easily definable. We know it from law that must adjust to the circumstances. But the whole point is that every cell memorizes the world differently. allow equal variations of traits, and only our dimensionality allows biological evolution, because every single biological cell and every one of us is distinct and different. If you were creatures in 10-dimensional space, you would be the same, because there is no exotic R4 in such a dimensionality. 10 to the power of 30 is the estimated number of living cells in the biosphere. This is the estimated number of living cells and neurons in the human brain. And 10 to the power of minus 44 seconds is the Planck time. So simple calculation shows that all those biological cells that are alive at this very moment on our planet, if they were to conduct quantum measurements, each quantum measurement within the Planck time, then all of them would make those measurements in 10 to the power of minus 40. And in any case, no delay, no freeze would be observable between subsequent measurements. Few years ago, we've learned about the assembly theory. I wish I have learned about it earlier, but the assembly theory became famous after Leroy Cronin, who discovered it, published the article in Nature. The famous article, Assembly Theory Explains and Quantifies the Evolution. So this theory is very elegant and very subtle, as he puts it, and it's uncharted territory. It introduces the notion of an assembly step consisting of joining only two objects. Because of this assembly pool, if we consider three objects, then perhaps we should say which two of them joined the first, and the pool would be different. So we can consider only two objects as in an assembly step. Then the assembly index of an object is the smallest number of steps required to assemble it. The assembly depth is the maximum depth of that this object was assembled from. And the assembly index is computable, unlike Kolmogorov complexity, and captures the structural information about the object, unlike Shannon entropy. Because of these two objects, we think that perhaps the most natural way to capture the assembly theory would be the spaces of strings, because we can always say that there is some left part of a string and some right part of a string. And here we got string 0101, which is assembled in 3 steps with the assembly depth of 3, but it can clearly be assembled with 2 steps only if we reuse the subunit 01. This example is traced simply. So we aim toward such a string, and this is another one. And after each joining step, we update the assembly pool, and only within 3 steps we reach the target here, but we need 6 steps to reach target here. So this is a bit string of the maximum assembly index of 6. Of course, we could assemble this string in 7 steps, both of these strings in 7 steps without an assembly pool, but it's not the point of assembly theory. The gist of this theory is that information once assembled can be reused. Now, this is an example of a minimum assembly index string, and such a string can contain at most 2 distinct string symbols if its length is the power of 2, like 2, 4, 8, 16, and so on, and at most 2 distinct symbols otherwise. So DNA RNA cannot represent a string of a minimum assembly index without violating the Chargaff rules, because it requires 4 nucleobases to be defined. Beam mutation was an idea that we devised while considering the binary strings, because the initial assembly pool contains only 2 bits, I mean 2 symbols. We decided to define only 2 commons, like 0 take the last element from the pool and 1 take the last 2 elements. And what was revealed is that such a binary programs assemble strings being the products of the Fibonacci numbers, and in most cases the assembled strings have the assembly index equal to the length of the program, which means that these programs are elegant. I mean, the shortest one capable of assembling a given string. But it turned out that there are exceptions. Namely, some programs turned out not to be elegant, and some programs produced strings that didn't have the minimum assembly index. Also, the frequencies of zeros and ones turned out to be related to the golden ratio. So there are plenty of bounds, and in particular concerning the strings of a minimum assembly index. It is natural to divide the length of the string into sections corresponding to the subsequent powers of 2, like between 4 and 8, between 8 and 16, 16 and 32. And the strings having lengths of powers 2, 4, 8, 16 have the assembly indices equal to this power. These are these ones. Then we have bounds on the assembly depth of strings having the maximum assembly index. This is the ceiling of the logarithm with space 2 of n, which with n is the length of the string. And this is intriguing. The black curve is the Chanda-Sutra method. Namely, this is the number of steps required to reach 1, starting from an integer, following the 2 simple rules. If the number is odd, then subtract 1. If it's even, divide it by 2. So from 15, we require 6 steps to reach 1. But the assembly index of a minimum assembly index of a string having length 15 is 5, not 6. Namely, join 0, 1, join 0, 1 with 0, 2 steps, join this doublet and triplet with each other, 3rd step, 4th step, reach the 10-bit string, and 5th step, make the 15 long 15-bit string. But this string is not balanced because it contains only 6 ones and 9 zeros. So it's not a black hole, because the black holes are balanced strings, and black holes are here given by the Chanda-Sutra method. These are these exceptions in imputation, in particular for strings of length 8, 16, 24. We are researching the subject, but we are not assuming where does it go. 4. This question why 4 would be particular. Where we have exotic 4, because the 4-dimensional space is the space in which there are 6 regular polytopes, and this is maximum because in any other, of course, in 2-dimensional space there is infinite number of regular figures, but in this is an exception. In 5th, 6th, 7th, and so on dimension, there are only 3 regular polytopes. 4 is the 1 unit of a black hole entropy. This is the first known prime number. This is the shortest string with 2 assembly indices, which is also kind of strengthens this Bekenstein-Hawking entropy. And what is interesting is the general formula for a surface of a ball in a complex dimension resolves to such a form containing a trigonometric form, and this form vanishes if we substitute r equal to 1 divided by square root of pi, and this is this would give the area of 4 in a regular form. So I mean this is also this radius corresponds to the 1 unit of black hole entropy and is given by the general formula. Another publication that is should be soon published by Institute of Physics in a conference series relate to our research on the fine structure constant that was reviewed in graphene. Namely, it turned out that there are perhaps two, or even more than, like there is alpha is the regular fine structure constant, and we found three other fine structure constants related to each other. But they are related with the same formula with the elementary charge. Elementary charge defines both matter and antimatter, and there is no elementary mass concept. From the universality of a black hole entropy, we extended it to all black body celestial objects that emit black body radiation. We received the complex gravity and complex temperature, a kind of an extension of a Bekenstein-Hawking temperature, which turned out to reduce to the regular black hole gravity and temperature, but also in moduli. I mean, if this complex number is multiplied by the complex conjugate of itself, then this factor would also vanish. So your peculiar result on bioelectricity are, I believe, might be related to our results. And this is a summary of what we have. So we have a definition of a beat as a spherical Planck area in units of the negative speed of light. We propose that the interface of perception is a sphere in three-spatial real dimensional imaginary time, but of course it shouldn't be simplified to thinking that we are like geometrical balls in some black universe. This is not what it's all about. Namely, the sphere is capable of memorizing one of this. This is one parameter that parameterizes the black hole in a curvature. And in case of the charged entities, charged celestial objects, these neutron stars and white dwarfs, we would need some other mechanism to store this second parameter, namely the electric charge. So perhaps it's hidden in some different dimensionalities, in a way tangential. So we propose this two Pythagorean relation with the speed of light and Planck acceleration as hypotenuses. The imputation might be perhaps a mechanism for the evolution of information. While we were very happy to find that the article saying that agency and cognition are fundamentally not computational, because we believe that it is so, and it is related to the notion of the fractional triangles that perhaps during the evolution of information expand to becoming a regular Planck triangles capable of carrying a bit of information. We have found a vast non-physical latent space of patterns, bounds, and rules within the realm of assembly theory, and this is there is a lot to discover. Well, where could it be used? There is an unexplained cosmological phenomenon called axis of evil, because it says that the plane of the solar system is correlated with the observed microwave background radiation. I think it's related with the fact that these planets are in motion, and they introduce this effect, meaning that every planetary system would have its own axis of evil. Of course, this cannot be experimentally confirmed, I'm afraid, at this moment.
Well, there is the ball lightning, unexplained physical phenomenon, also related to sphericality. This sonoluminescence, which I believe is explained because I found a paper that explained this sonoluminescence as the Bekenstein-Hawking radiation, meaning that this is in fact a small black hole that collapses, radiating its energy. In particular, mantis shrimps are known to produce those sonoluminescence, and that is why they have these 16 various detectors of light in their eyes, each capable of moving independently in order to control this phenomenon. Thank you very much.